Earth Systems 3209, Unit 1, Introduction to Earth Science, the Evolution of Planet Earth. References can be found in the textbook in Chapters 1, 17, and Appendix A. This presentation will focus on Unit 1, Topic 2.3, which will discuss the formation of Earth, which is also known as the Geosphere. Focus on describing the Earth, segregating into layers, and identifying the segregation was influenced by radioactive decay, the collision of particles, gravity, and density. According to the solar nebula hypothesis, to understand the origin of Earth, we must focus on how Earth formed billions of years ago. Earth formed as a direct result of the solar nebula hypothesis, which states, a great cloud of gas and dust shrank under its own gravitation and formed into the planets and natural satellites that make up the present solar system. Text references can be found on page 19 and page 20. Early in Earth history, it is thought that the Earth was not always layered as we see it today. In this diagram to the right, we can see that the Earth was much like the Moon. It consisted of a solid mass of rock, which was homogeneous throughout, meaning the Earth's interior was the same as the surface. Also, you'll notice that there is a lack of atmosphere or any surface water on the early original Earth. Some scientists suggest that Earth was not like the Moon, not like the Earth as it is today, but much like the Moon. The composition of the ancient Earth was thought to be the same throughout, and therefore separated into layers later in Earth's history. Shortly after the Earth formed, the interior segregated and took on a layered structure. Heat generated from the collision of particles and the decay of radioactive isotopes produced heat and was responsible for melting of Earth's interior. By referring to the diagram to the right, we can see that the Earth's interior is presently melting, and we have a thin outer crust, which we see volcanic gases escaping through. As the Earth's interior melted, gravitation took over and caused great streams of hot, heavy liquids to move toward the center of Earth and melted the lighter material, which forced it to the surface. This sorting of material by density early in Earth's history is still occurring today, but on a much smaller scale. Gases that are released from Earth's interior are released through volcanoes. As seen in the diagram to the right, we can see the Earth interior beginning to segregate, where the heavy materials move to the center and forcing lighter materials such as silicates to the surface. Once the segregation of Earth continued, we see different layers forming on Earth's interior, as seen in the diagram. The heavier material, such as nickel and iron, which concentrated close to the Earth's center, formed the inner and outer core, which is seen in the diagram here. Inner core surrounded by the outer core. The lighter and less dense material moved upwards closer to the surface and formed the crust. The outer solid layer of Earth is what we call the crust, and is primarily made up of silicates, which are lighter in density. The material in between formed the Earth's mantle and continues to separate today. In the diagram, the red portion between the crust and the outer core is referred to as the mantle. Also going hand in hand with the segregation of Earth's interior was the formation of the atmosphere and the hydrosphere. The atmosphere and oceans, which is also called the hydrosphere, formed as a result of the gases that are given off by volcanic outgassing throughout Earth's history. This topic will be discussed in a future presentation. Let's look at some examples. Example 1 states, which factors were most responsible for the segregation of Earth into layers? Our choices will be Earth's rotation, meteorite impact, radioactive decay. Choice B, Earth's rotation, volcanic outgassing, and density. Choice C, gravity, volcanic outgassing, meteorite impact. And choice D, gravity, radioactive decay, and density. Throughout the segregation of Earth, we stated that the decay of radioactive elements partnered with the collision of particles and also gravity will be responsible for segregating the Earth into layers. Therefore, the answer in this case would be D. Gravity, radioactive decay, and density were responsible for causing the Earth to segregate into layers. Example number 2 states, what is thought to be the primary reason for Earth's internal temperature remaining higher than expected? Our choices in here: A, friction caused the rubbing of plates. B, gravitational pull from the moon. C, increasing sedimentary layers on the surface. And D, radioactive decay of unstable elements. As we stated in the process of Earth segregating into layers, radioactive decay was one of the primary heat sources that caused the Earth's interior to heat up. So in this case, our answer will be D. Your turn. Take the time to complete the following question. The solution will follow on the next slide. Question reads, how does the solar nebula hypothesis explain the segregation of the geosphere into layers? The solution to the preceding problem, how does the solar nebula hypothesis explain the segregation of geosphere into layers, focuses on several points. First point, stating billions of years ago, the decay of radioactive elements, coupled with the heat generated by the clouding of particles, caused the Earth's interior to heat up and melt. As the interior heated up and melted, this allowed a differentiation of Earth's interior based on density. The denser elements, such as nickel and iron, would sink to the interior, while the lighter rocky components, such as silicates, floated outward toward the surface. This separation was based on the density of the different materials. This segregation by density is thought to be still occurring today, but on a much smaller scale, and was responsible for the apparent layering of Earth's interior into layers of material with different physical properties. The solution to this question can also be seen by referring to pages 19 to 20 in the text on the second paragraph from the top. An additional question and solution, which basically states the same question as before, could be read as follows. Describe the processes that could lead to the segregation of layers within a newly formed planet. In this case, a newly formed planet would be much the same as the Earth's original planet that formed according to the solar nebula hypothesis billions of years ago. And according to the segregation of Earth's interior, we could look at a newly formed planet heating up as particles collided and also if it contained radioactive elements as they decayed. The interior would melt, the material would segregate based on density, heavier going to the center, lighter materials going to the surface, and as a result, you would have a layered planet. In summary, when describing how Earth segregated in the past, include the following main points. The primitive Earth was one homogeneous solid sphere. Therefore, it had no layers. It was just made up of one solid rock type that consisted the entire geosphere. Include that the Earth's interior heated up as a result of, number one, the collision of particles, which generated heat due to friction, and number two, the decay of radioactive elements, which when they broke down, they generated heat. Two of these points together created the interior of the Earth to heat up. Point 3, gravity caused the more dense materials such as nickel and iron to move towards the center of the Earth, which formed the inner and outer cores. In doing so, the lighter materials, such as silicates, were forced toward the surface, which formed the crust. The material in between the crust and the outer core was called the mantle, and this material is still segregating today, as we see through volcanoes that are continuously erupting and bringing the molten material to the surface. Throughout the segregation process, volcanic gases escaped, which eventually formed the atmosphere and the hydrosphere. And this topic will be discussed in a future presentation.